All right, so welcome back to MAT150, everybody. And what we're going to be doing today is we're going to be talking about the chapter on regression and correlation. And that will finish the instructional piece for MAT150. On Thursday, I'm just going to leave it open for a big question answer session for you guys. So I'm not going to prepare any lecture content. You can ask anything you want about the test, the homeworks, the quizzes, and stuff like that. What I won't do is answer questions about like, what does my average need to be to get a B or an A or something like that. It'll be questions that you have about the course content, something like from the books, the notes, or anything like that. One thing that I'm going to mention, take a couple minutes just to clarify because I'm getting a lot of emails about it. Been having like a dozen people email me, Professor, what's my average? Like, what do I need to get an A? What do I need to get a C? Your exam, your semester grade is only based on the average of your 4 test scores. So if you got, let's say 80 on each exam and you want to know what do I need to get to make an A in the course, make up another number for your final test, like a 90. If you think you can get a 95, use a 95 and average that with the other scores. If you're coming out above 90%, there's your answer right there. So we're going to go ahead and turn over to the presentation screen. We'll start to talk about the regression and the correlation. There's not a PDF chapter on that in the website. That's because I just really don't have one. So all the information that you're going to need for the exam will be right here on the lecture. It's going to be a much simpler lesson than anything we've done so far. That is, we're not going to be doing any crazy formulas, any computations or anything like that. And the reason why is because we're going to do just barely an introduction into regression and correlation. You could spend probably like a whole entire semester on that. And the mathematics department just requested that we add it into the curriculum about 2 years ago. To give you an idea of how deep regression can go and correlation, when I took the class at Lehigh, I had to do 5 calculus classes before they would let me into the regression course. And there's a lot that happens behind the scenes to make equations work that we're going to see. And most of what we're going to be doing is just the application part. So we don't have to worry about all that stuff that's, complex and going to give you headaches and things like that. Anybody have any questions before we start up? Okay. I'm just going to take a minute to copy down a couple more names, or actually, I think even easier. See, I was going to take a photograph of it. Let's see if I could do that instead. That was easy. And a couple more names. Now, if you are on black screen on the phone, like if it just says your name, I do not write that down for attendance, and those people get exited from the Zoom. So just something to bear in mind, similar to what we did in the last course. I mean, the last meeting. Okay, I'm going to turn us over to the presentation screen. Stand by just a minute. And if I do this right, you're going to see just a cat on your screen. Part of the little cartoon here. All right, now the cat went away. It'll just say regression and correlation. If that's what you see on your screen, you did everything exactly correct. Okay. So when we're talking about chapter 9 and chapter 10, when we're doing correlation and regression, that's just fancy talk for learning how to set up prediction equations. And that's something we haven't done at all in the math course. Most of what we've done has always been probability, hypothesis testing. So if you were saying, when do I learn how to make a math prediction, figure out what's going to happen next year for how much money is going to be in the stock market 4 or 5 years in stocks. This is kind of the thing that we're going to get into in this class. The whole idea with predictions, when it comes to regression correlation, the whole idea is we're predicting stuff that we can't see based on information that we can see, that we do have. So we're using what's visible to tell us what we want to know about stuff that's invisible. And if we want to know, for example, how much money is going to be in our savings account next year, Money is always important to us. So that's nice to think about. How much money am I going to have? I might base that on something like, what's my income level? What's my income level next year? And how can I use that to figure out the savings account the next time? So that's an idea of basing a savings account on income. GPA is always on everybody's mind, especially when the semester starts to end. So how many hours do I have available to study? I could use that to figure out what my GPA is going to be, because if I'm not studying at all, I'm probably not going to have a really good GPA. But if I'm studying like 40 hours a week, I'm probably walking out of here with a 4.0. So I can base GPA on what our number of study hours is. Anybody have any questions so far? Okay. And oh, I need to open up the chat window so I could see that. Right now that's invisible to me. Pop that open. Okay, that's much better. I just need to move that so it's in a high vis position. Right now it's covered up on the screen. I'm just gonna get everything in better position. Outstanding. Okay. All right. So sometimes a lot of us like to go out and exercise. And maybe we can figure out how much time we're going to spend exercising based on something like how many hours per week that we're going to work. If you're working more, you're probably going to have less time to spend exercising. But maybe if you're running a gym and you happen to know, are people working full-time or part-time that come to the gym, that could help you figure out how many hours should you have the gym open to keep people happy. So we're going to get into some definitions and terms now. And the very first term that we're going to do is something called a dependent variable. So if we talk about GPA, we could say, based on the slide we just talked about, GPA is something that depends, that's why we call it a dependent variable. It depends on something like how many hours you studied. And we're going to call the number of hours that we studied our independent variable. And let's do a few combinations of dependent variable, independent variable, just to make sure we kind of get the flow. If we are going to talk about how much money we have for a vacation, what's stuff that you might be able to base your budget on? What do you guys think? Or kind of just gave it away by mistake. If you're going to figure out how much vacation budget you have, what can you base that on?
How much money you have?
Absolutely, yeah. Like if you're a travel agent, do you want to know how much money your clients have? Yeah, because it's going to tell you who's going to spend big, who's not going to spend big. So something like your income level would give you information about how much money you're going to splurge on a vacation. And we had spoken about exercise time. That would probably be based on something like hours that you have available for work each week. Any questions on the concept of independent variable and dependent variable? Okay, so if we pick one of these to kind of focus in on, like we may as well do GPA because everybody's always wondering about GPA when the final test comes out, and for good reason. Right now, we're just talking about basing on hours studied, but what other things could affect your GPA, guys? Besides just how many hours you studied?
Test scores.
Okay, test scores, what else? Keep going. If you want, you can send your answer into the chat window.
Homework grades.
Homework
grades.
How about things like outside the classroom? Like, are we working? Could it have to do with how many other classes you're taking? Just to kind of get us thinking in the right area, some of the other things that could affect the GPA would be like how many other classes you have. Because if you are taking a whole bunch of other classes, then it's going to be harder for you to devote more time to any one class.
Athlete.
Yeah, sure. If you are an athlete, it's probably going to be taking time away from your academics. So that's a great example of something else. Like, how many sports are you involved in? Perhaps it's something like the number of hours a week. We kind of talked about that already. Your income level could loosely affect your GPA too. As we have more money, like we'd like to think we have lots more money for tutoring and stuff like that. But are there people who have lots of money, but they don't like to spend it? Probably. So it might be related to GPA, maybe not as strongly as some of the other things though. Anybody have any questions so far? Okay. If you do not have a question, please go ahead and mute yourself because we're getting some background noise that's coming in and somebody just might not have their mute switch on. Ah, great, thanks. Okay, so we have all these different things. We're talking about how many classes you're taking, what's your credit load, how many classes you attended, how many hours a week, income level. If you have all of these different ones to pick from, like how would you know which is the right one to use to predict your GPA? And the answer is going to be something called scatterplot matrix. Has anybody not seen scatterplot matrix before? Okay, so that's good. So we're going to take a little bit of a look at scatter plots. And what we're going to do is we're going to list up one of the examples that we were just using, GPA and classes cut. If you are cutting more classes, like you're increasing the number of classes, what's probably happening to your GPA, everybody? Like if you cut the whole entire semester, what's probably going to happen to that GPA? Yeah, Ashley says it'll go down. Exactly right. I agree with Ashley. So if we set up a scatter plot here, and on the x-axis, we have number of classes cut. On the y-axis, we're showing our GPA. It's generally going to be the case that if we start to pump up the number of classes we cut, the GPA is going to start to nosedive. That's why in the upper left here, we're showing we've got somebody that didn't cut any classes at all. They were there for most everything. So their GPA is very high. As we start to increase the number of classes, what's happening to that GPA? Starting to go down and down and down to the point where we cut as many classes as we can, like there is no GPA anymore. Anybody have any questions about how we're using the scatter plots? Okay, so let's go in a different direction. If we do GPA versus classes attended, what do you think is going to happen to the shape of the scatter plot this time? Before we were kind of starting at the upper left and we were going down to the lower right. What's this one going to do we think?
It's going to start at the bottom left and go to the upper right.
Okay, somebody's saying start at the bottom left, go to the upper right. It's pretty close to what's going to happen. In fact, it is what's going to happen. So once we start to attend more and more and more classes, the GPA is going to go higher and higher and higher. So let's take a look at a couple more, just to make sure we really grip into it well. If we talk about GPA versus how many classes we're taking, we would tend to think that as you start to load up on classes, is it going to be harder or easier to get your A's and B's? Okay, Victoria is saying harder. Ardiana, thank you. Jessica, excellent. You guys are getting this right. That it's not going to be a direct connection as much as the stuff we were looking at above. I mean, we would tend to think that as you take more classes, it's going to be harder and harder for you to maintain a GPA. But do we know somebody, even if it's us, that we take 6 classes and we're walking out of here with a 4.0? Some people can do that. At the same time, though, do people take just one class and flunk it? That happens also. So what do we suppose is going to happen to the scatter plot this time? Is it going to look as tightly oriented around a line as it is in the top, or is it going to spread out? What do we think is going to happen? I'm looking in the chat window for answers. I know you guys are there. I can see you. Ashley's saying more spread out. Let's see what everybody else thinks. Do we agree or disagree with Ashley? Okay, Natalie says agree. And Victoria says agree. Ardiana, excellent. So you guys are all correct. Bullseye. If we bring in the scatter plot this time, it's going to be a lot more scattered, literally, because the relationship this time is not as direct as before. If we look at something like GPA and how much money you earned, what would we think the graph would do this time? Would we expect a direct or an indirect relationship, or like nothing at all? Ashley's saying direct. Jaleesa says indirect. This is exactly correct. So if we were looking at the same kind of setup, GPA and weekly earnings, there's going to be just kind of thrown out there in the scatter plot. We're not going to see a whole lot of anything in the scatter plot, and it's not going to point us in the direction of having a good independent variable combination. Okay. So if we're looking at millions of all these different scatter plots, how do you figure out which one is the best one to use? And the answer is right here on the next slide. What we want to do is we want to find the scatter plot that's the closest to forming a straight line. If we do, it's called a strong linear relationship. If we have a scatter plot that's showing us dots that are drifting really far apart away from the line, such as the one on the lower left, that means there's very poor predictive power. It means the dependent variable and independent variable probably have no relationship to each other. So one is not going to help you predict the other. What about the one on the lower right? Does that look like it would make almost a trick question? Well, actually, it is a trick question. The one on the lower right, would that be good to use for independent and dependent variable combination? I'm just going to give you the answer to that. That is no, because they do kind of make a line, but what's wrong with the line in that? Any guesses? What's wrong with the shape on the lower right? What shape does it make? Okay, Victoria is already saying bell-shaped, very observant, Victoria. Yeah, we got like kind of this rise and fall. Now, it looks like you could trace a line through that with a curve, but the catch is we're using simple linear regression. And simple linear regression means you have to have a very straight line. Like you can't have bends and curves or anything like that. They get to that stuff in statistics too, and the equations get, well, we'll say we really go up a level when we do that. And this simple linear regression practice is just about straight line relationships. Anybody have any questions about what type of pattern in the dots we're on the lookout for? Okay, so if we take what we learned here and we bring it back into the scatter plot concepts, what we would see is the scatter plots in the top row appear to have the best relationship between the dependent and the independent variable. So that's how we could figure out exactly where we want to go. Okay, so if we're looking at lots of different scatter plots and we're trying to figure out which one is the most straight line, you kind of burn your eyes out detecting that visually. So how do you do that mathematically? Like, what's the fast way? And the fast way is something called a correlation coefficient. The correlation coefficient, you guys do not have to calculate. You'll see why when you see the formula. We don't have to calculate, we just have to know how to interpret it. And this is the part where if we were doing this for real in the class, we would all be on Microsoft Excel right now because the formula would just get way beyond what we can do pencil and paper. All you have to know about the correlation coefficient is that when you calculate it, it's trapped between -1 and +1. If it comes out to be something really close to 0, it means that you cannot use the independent variable combination. You have to pick something else to do your prediction, meaning you have to pick a new independent variable. You want to be really close to -1 or really close to +1. Any questions so far about the correlation coefficient thing? Okay, so how do we take this and relate it to the scatter plots? If we bring up 6 of them on the screen here, what I want you guys to do is look at the scatter plots to the far right, where we have C and F, that's Charlie and Fox. What do we notice about the shape of the line when our correlation coefficient is at either a 1 or a -1? What's that telling us? Like, what shape do we get? Victoria says straight line. Victoria, you are correct. Outstanding. Let's just look at the one in C, graph Charlie for the time being. If we have the correlation coefficient at a 1, that's what we call a perfect positive relationship. When your independent variable goes up, your dependent variable is also going to go straight up all the time. If the independent variable goes down, the dependent variable is also going to drop 100% of the time. Something that would be similar to that, think of peanut butter and jelly. We all used to eat that, or at some point or other we did, maybe. If you have a whole bunch of people that start to buy a lot of peanut butter, what's probably going to happen to how much jelly a store is selling? What do we think, everyone? If we buy lots of peanut butter, what's happening to jelly sales?
Decline.
Yeah, more jelly, right? They're going to go up. So we buy more peanut butter, jelly goes up. That's how they explained it to me at Lehigh. They were explaining in peanut butter and jelly, and I thought I loved it. I can understand this. I'm hungry. This is perfect. I like where we're going. If we have something like below that in graph F, like Foxtrot, it's a perfect negative relationship. So perfect negative relationship, if the independent variable starts to increase, what's the dependent variable going to do, everybody? Which way is it going to move? I feel like I'm waiting for a hitchhike ride. What's going to happen if independent variable goes up? What direction is that dependent variable going to move? Okay, Julissa is saying down. Exactly correct, Julissa. You got it in one shot. Right on, Victoria. Okay. So when one goes up, the other moves in the exact opposite direction. Now, here's what I want you guys to see. When we're moving, and I think everybody can see my pointer here, when we're on the graphs in the middle, Bravo and Echo, B and E, as the lines start, not the lines, as the dots stop holding the form of a perfect line, what's happening to that correlation coefficient? It's getting closer to 0. It's getting closer to 0. What happens if we go all the way to the left? We look at A and D. The dots are they're spreading out even more. So our correlation coefficient is getting even closer to 0. So again, just to recap, the closer we are to -1 or +1 means you have a great dependent and independent variable combination. As you start to get closer to 0, it means that combination is not very good. Any questions about this?
So sorry, you said the independent variable are always inverse?
Yeah, if we are on a -1, meaning the correlation coefficient is a -1, it means that when your independent variable goes up, the dependent variable would go down. And a good example of that would be cutting classes. versus your GPA. Because if we increase the number of classes you're cutting, your GPA is probably going to start to go down.
Okay, thanks.
You're welcome. Anybody else have any other questions? Okay, so let's take a look at the formula. I mean, just to say we saw the formula, and don't worry, I'm not going to ask you guys to calculate the formula ever. This is what it looks like. And I'm going to actually make it a little bit bigger because to me, it's even small. And now you'll probably start to understand a little bit more about when you get into statistics too, you're completely on the computer for most of your classes because your formulas get so intense, you can't do them by hand anymore. You would never finish them. If I had to do that one by hand, I probably wouldn't get it right either. I'd have to go to Excel. Any questions on anything we've discussed so far before we take a look at an example of what happens where somebody actually did start to work out the correlation coefficient? Okay, so let's take a quick little look at an example that the book gives us. And in the book, well, I mean, you guys don't have the book, but in the book that's designated for the course, there's an example in there, and it has to do with predicting how much money a car company is going to make. In particular, it's a company that rents cars, and the idea was, let's base your revenue on how many cars you have to rent. If you have more cars, probably a pretty good chance that you're going to be able to make a lot more money. When we look at the scatter plot, that's kind of the trend we see. The fleet increases, the revenue goes up. And all we're interested in right here is just taking a look at what you have to do to complete that correlation coefficient. This is what you have to start to do. We have to do lots of columns and lots of totaling and lots of multiplying, lots of sums, and it just gives you a headache after a while. But this is just to give you an idea of like what Excel would be doing behind the scenes if you programmed it with two different variables, you fed it the data for each variable, and you asked it to execute a correlation coefficient. In the bottom down here, we are seeing that the correlation coefficient is about 98%. So what that means is we have a pretty good independent variable that can be used to predict that dependent variable. Layman's terms, that means car fleet is going to do pretty good for you to tell you how much money that car company is going to make. Any questions about any of this so far? Okay, there's just actually only a few more slides left. We'll probably finish early today, which is okay. Okay, so we've been talking for quite a bit about how to figure out which independent variables and dependent variables would be the best if you wanted to make a math equation to pick something. Now, how do you take all that and actually build a mathematics equation out of it? And the answer to that, let's take a look at one of those examples we were just looking at before. This is the one where we're talking about car fleet versus car profit. Profit of that car company. And what we have to do to make our equation work, we have to go into our scatter plot and we have to figure out how to set an equation line up so the line goes right through the middle of the dots. And the equation of the line in turn gives you everything you need to know for predictions. For example, if we plugged into the equation of the line, there's this car company with a fleet of 35,000 cars. How much money is it going to make? What would be the amount of profit that we expect them to do? About how much money? And remember, it's in billions. Okay, Jaleesa's saying, Elisa's saying, rather not Elisa, Ashley's saying, right about $5 billion, and that's exactly right, spot on. This information is really taken from the author from actual information they have about profitability and fleet size. So it's pretty cool that you can actually use it in the industry to get some preliminary intel on what a company is doing. like they actually went out and they had to research a data set on the car fleet size that would give them this equation. Okay, so if we know that we're going to take a line and fit it through the dots and use that for our prediction power, the only little problem is, how do you know exactly where the line should be? Like, how do you know it shouldn't be here where the purple line is, or maybe over here? So it's kind of hard to figure out, like, exactly how do you know where to drop the line in there? And statisticians couldn't figure it out either. So what they did was they came up with this little thing called least squares regression. And this is how it's done. Now, what we did in the scatter plot is we spread dots out a little bit more so we could see what we're going to put on screen without too much crowding. And the way least squared regression works is we're going to figure out what's the vertical distance between each dot in the line. And if we actually go through, like if you do a regression class, they're actually going to make you measure this by hand just to get the idea of what's happening. So we have all these distances. What statisticians figured out that you would be able to do was find out where to put the line so it minimizes all of these distances. And you'll know you have the right line when it's the one that minimizes the most all the vertical distances that you see on the screen. And that's how they figured out to do it. The equation is going to end up taking the form y equals a plus bx, just like we used to do in the algebra class. And to show you how they actually get those numbers, if we go back to that car fleet, on the screen, we can see like all the totaling and the summing that you have to do to get the terms figured out that are going to be your A and your B. At the end of the day, here's what I need you guys to know. I'm going to put a little pointer in here just so we all know. We shall be able to see that blue arrow. What I need you guys to do is to be able to recognize the form of this equation. I will ask you this on the exam. Like I'm going to give you different equations. I'm going to say like y equals x cubed, y equals 2 plus the square root of z, y equals 3 plus 0.5 times x. And I'm going to ask you which one takes the form of the regression line for simple linear regression. And this is exactly the form that we need to recognize. There's going to be a numerical term and then another term that's going to be an x with a number attached to the front. So that's going to be your coefficient on the x term. And this one is letting us know that your equation would be 0.396 plus 0.106x. And if we were to go and put different numbers in there that correspond to thousands of fleet size for a car, it's going to tell you right back how much money that company would make. Anybody have any questions? Okay, so we're going to stop here. We're essentially done with MAT150 right now. We're not going to go further into any cases or examples or anything like that because I don't want to put you guys on overload. This is everything that you need to know for the regression and the correlation chapters. And I just want to pause to ask what questions you guys have about regression and correlation. Okay, so just to recap how we're going to play out the rest of the week. On Thursday, I'm not going to do a lecture style. I'm just going to make it a big question and answer session. So you guys have plenty of chance to come in, ask any questions that you have concerning like the homework, the practice exercises, anything that has to do with like your average, the course, the lectures, anything such as that. And on Tuesday, we're going to take the examination. It'll be emailed out as usual. You'll have 24 hours to respond with the results. If you missed at least one examination or you submitted it after the deadline, you're going to be on the cumulative final. I think we got like 5 or 6 people taking the cumulative final, and you're going to start off with exactly the same examination everybody else has. After those questions end for like correlation and regression, there's going to be another section that'll say, if you missed a test, like this is your next set of questions. So I'm going to turn us back over to the main screen here. I'll stick around for a couple minutes in case anybody else has questions on anything. Otherwise, thank you guys for being such an extraordinary class. Always a pleasure to be here with you on Tuesday and Thursday at 3:15. I loved every minute of it. I always do. Wish everybody a terrific week as we're getting ready for the finals. And have a great Tuesday and a great Wednesday. We'll see each other back on Thursday. Attendance is not mandatory for the Thursday class. What I'll usually do is hold the video room open for probably half hour, 45 minutes. And if nobody's there, I'll just close it out at that point. I'll be there for any questions that you have though. And I'll stick around now in case anybody has any concerns or comments or questions.
Thank you.
Thank you. Have a great day.
Thank you.
You too.
Thank you, Professor.
Professor?
Hi.
I have a question. How do you find out your grade again?
Okay, Roberto, the grade is going to be the exact average of 4 tests. So if you've got 380s and you're trying to figure out what could I get on the final, if you think you can do, let's say 95 on the final, go ahead and take a 95 and add it to the 380s. The average will give you exactly what your mathematical average is.
Okay.
The only time it's going to change, are you on the cumulative final or the regular final?
The cumulative.
Okay, so you're on the cumulative final. I'm glad you asked. Yours is going to be out of more points because there's more questions on it. Usually it's probably going to be about another 30 points or so.
Okay.
Anybody else have questions? Okay, if nobody else has any questions, I'll go ahead and close us out. Thank you, Ardiana. Thank you, Jaleesa, as well. And everybody have a terrific afternoon.
Thank you.
You too.
Thank you, Roberto. Que pase muy buenas noches.
Oh, I forgot. It's an off-topic question I have.
How can we help?
But you know how you want to, when usually you want to drop a class?
Yes.
Like, is there a date that you can